So good morning, friends. So we'll talk a little bit about our journey, specifically about the in-store kiosks. We are updating them. Um, Before we begin, who hasn't heard of or been to a Wawa? Okay, all that slide is not necessary, I suppose. So what do we offer? We have a gas station, we have EV charging, we charge Teslas, convenience store. We also have made-to-order food and beverages. You could go to a kiosk, customize them. You can order them online as well. You can also order them on your mobile phone app. We also offer catering. Also, by the way, if you don't have the app on your phone, please download it. It's 15 cents off every gallon. So gas is expensive. Please use that. We'll talk about made-to-order food and beverages. So they can be, as I said, can be ordered on mobile phone or web. Also in store, where you could go to the store, customize whatever you want. We have approximately about 4,800 different variations of products you can purchase on a kiosk. And we have about 4,000 plus kiosks in our network. So like every store has a couple, and then we have quite a few stores. So it comes out to be around 4,000 of those devices. So what exactly are we trying to do? We started to essentially in software engineering parlay refactor the entire experience we have, like on web, mobile, but also here talking about kiosk. We're changing how they look and feel. We're changing how they essentially, how quickly we can change the look and feel, how quickly we can unlock items, based on availability. So essentially, being able to show the menu, ease of navigation. I mean, if you've been to a Wawa, to order at a kiosk in a Wawa now, you'll feel it kind of looks a little dated. So we are changing that. Well, there's a couple slides down. I'll show you exactly how it's going to look like, kind of like a sneak preview. Ability to get latest menu updates. So if you want to try, we want to merchandise, say a net new product, we want to be able to support that. Lock and unlock updates. So for example, if a store runs out of, say, tomatoes, we don't want customers to be selecting tomatoes because we can't fulfill the order. Offline capabilities, networks, they lose connectivity all the time. We don't want to, stop customers from placing orders because we are not able to, say, either connect to internet or there's a disaster, natural disaster. I know we have stores in Florida. Hurricanes come all the time, so we definitely have requirements on having offline capabilities. Inventory, of course, you buy, you put cucumbers, we need to reduce that from the inventory available at the store, so we can order more. Secure communications, of course, that's just how communication is supposed to be. Deployed to 900 plus stores, 4,500 plus devices. So essentially, I like to use the analogy of cattle versus pet. So this is not a pet. This is more of a cattle scenario where we want to be able to smoothly, roll out to, 4,500 devices as and when, we have updates. So our sprints are usually around 2 weeks. We try to get a new build out every 2 weeks. We want to be able to roll that out to 4,500 devices without issues. Analytics, we want to see, what's going on, how customers are interacting, what are they buying, what are they not buying, and how are they buying it. what flows they're going to, say if you're selling a whole lot of tomatoes, we want to know what product essentially customers are putting those tomatoes in, right? We want to be able to preview content and menus. So essentially, before we show a menu to the customer, we want to double, triple verify that that's exactly what they're going to see, right? Recommendations, of course, we want to sell. We're here in the business of making money. So, when customers are put in, say, Hoagies or breakfast burritos in their cart during morning time, we want to make sure not only we give them recommendations for something else, like cross-sell, but we also want to make sure that those recommendations actually honor time of the day. So we don't want to give dinner recommendations during breakfast time and so forth, or recommendations for, say, product which we don't sell at that store, or maybe the ingredients are locked out. So technology requirements, we are a 24/7 shop. You can go to a Wawa anytime and order on a kiosk. We do not have a concept of downtime. We can't do scheduled maintenance. So that's one thing we are working with. Multiple deployment zones or time zones. That's an upcoming requirement. We're expanding to CST or CDT. So you want to be able to handle, say, if you have a special menu for, say, Easter, right? At Easter starts at a different time in different time zones. So we want to be able to handle all that. A little different than web, because web is almost omnipresent. You can render on web and kind of goes everywhere at the same time. So it's slightly different than just doing web. We have multiple sources of data, multiple systems of records. So we have content management system, we have a catalog, and we are essentially merging those sources of data into a menu, which a kiosk can understand, right? Order of arrival is not guaranteed because we have multiple sources of data, managed by multiple teams. We cannot really guarantee, who's going to publish their data, first. Near real time, lock and unlock events. Store runs out of ingredient, they want to lock it then and there, because that's going to be a pretty hard situation if customers start, putting onions in their, Hoagies, and we don't have any onions to, put in the Hoagies. A lot of these events are actually store specific. So say a store in Florida would be having a completely different day than, say, a store in Virginia, right? Again, offline capability, I think I mentioned it in business requirements as well. We want to be able to, run our business when we are offline. So if there's a menu on the kiosk, it should work, even when the kiosk is offline, right? Customers should be able to order with or without the internet connectivity. The other thing is the hardware on those kiosks is rather basic. They still have, believe it or not, spinning drives. So we're actually, fixing a defect where, the image pulled from a spinning drive takes like half a second to render. So we're trying to cache them in main memory. Of course, monitor and both host and the app on all those 4,500 devices remotely. Same thing. Cattle. We need to monitor the cattle. Over the year app updates, we are spread out. So we can't just drive a truck and hey, I'm plugging in a USB drive and all those devices and updating them. It's not going to be possible, especially since our sprints are 2 weeks long, and we're constantly updating it. Especially if there's a disaster recovery scenario, it could be like whenever, instant. So we need support for app updates, and of course, we're kind of limited with a whole lot of things we can or cannot do because, it's a Microsoft Windows shop, all the kiosks run Windows, so kind of working with that. So the solution we chose for building our app, we chose Electron framework. Why we chose that was because it supports Windows. We cross-compile. Essentially, our pipelines are in Linux, but we are able to cross-compile it to a Windows exe. Has a Next.js front-end, Node.js back-end. So essentially, I'll talk a little bit more about Electron in the next slides. But it allows us to, use newer technologies, well, at least compared to what we have today. As I said, we have Linux pipeline. It kind of works okay, although there are some limitations. We tried working with MSI installers instead of NSYS, and it was just having a hard time because, bless you, we couldn't make it work because of some limitations on what Wine provides in compiling. Certain libraries, some DLLs were not available. I don't remember them exactly. But that was one of the pain points, that certain features of Electron framework are not really available when you're doing cross-compilation. Also, our devs work on Macs, and our pipeline is Linux, and our deployment environment is Windows. So we have pretty much everything thrown in, and it works. Yeah, it works. Supports app signing. So our app, we have a feature where we sign our app with our cert. So essentially, if some bad actor were to show up on a kiosk and magically we're able to install or try to install something on it, it just won't work because the antivirus we use only allows the app, only the executables signed with our app, with our cert, to be installed on the kiosk. So unless you're Wawa, your software cannot be installed. Auto updates, we support, Electron supports over-the-air updates. You're using Electron Builder for that. And then I think I already talked about the issues. Cross-compilation can be pain. It does not work with MSIs, so using NSYS installer for this. All right, so high-level design of the app. Has anybody worked with Electron framework? You have? Okay, cool. So essentially, it has the main process and the render process. And the way both work in our use case is through the IPCs. So essentially, we have a few different APIs we hit for doing our work, and the screens rendered essentially talk to those APIs or get data from those APIs using IPC calls. We can talk more. We have Joe here, our UI expert. So if you have any specific questions, we can go deep dive into that as well. So same exact thing. We have a render process, and then the main process is the one which actually talks to the external services. So for example, if we are, say a screen is painted, say a customer is selecting, whatever ingredients. So, and let's say we want to log it, or if there's any error, we want to log it. So essentially we call a debug, which actually invokes the debug in the main process through the IPC. Okay. Well, that's how the app we are launching very soon is going to look like. If you compare how the existing kiosks in Wawa look like, it is pretty different. I'll talk a little bit about what's going on here. So, and by the way, all this content can be changed near real time, pushed to stores near real time, and your menu can change near real time. I mean, like it's pretty fast. So we have categories on the left-hand side, and we have the marketing boards in the middle. They're all content managed. So if the merchandiser wants to do a different promotion, say for Siptopia, or yeah, we already have Siptopia and Hoagie Fest, say for 4th of July, if we want to run a new promotion, it's all supported with this new implementation we're doing. And yeah, these menus are actually also time of the day sensitive. So we are able to configure what people will see, what categories they can see or products they can see based on time of the day. So during dinner time, if the lunch is not marked as to be displayed during dinner time, it would just vanish. So let's say, come back, customer selects something, and then, they get to the checkout screen. Kind of wanted to talk a little bit about this screen. So you can see here on the right-hand side, if you can see the cart, the customization of how the customer has selected their oven roasted turkey hoagie, right? So at the bottom right, you see that complete and print order. That's actually an API call, which we make into our point of sale system. So again, through IPC, right? And the other thing I want to talk about is on top left, you see, you may also like, those are actually recommendations coming from a different API call, which we make to our integration platform, which is hosted in AWS. So, and again, if there's no internet, then we also have default recommendations. This is how our apps code pipeline looks like. Let's say a PR is merged, right? A dev, say, built a new feature out. We want to see how it's going to look in dev, and then of course, if smoke test goes good, we promote it to QA, and then on the production deployment cycle, it makes it to stores. The pipeline pushes it to Artifactory, and then use of Electron Builder framework to auto update the kiosks. But we also built an admin API on top of it, so we are able to do deployments in a canary fashion. So roll it to one store, one kiosk. Smoke test passes. One store. Like odd number of kiosks. So all the stores in, say, Philadelphia or Pennsylvania, kiosk number 1, let's launch it now, and then kiosk number 4, so that way, essentially, if there's a issue with that app update, the blast radius is pretty significantly reduced. And also, kiosk is a big money maker for us, so can't really screw up with that. Talking about the menus, as I said, they're real time, near real time. Nothing can be real time, so it's all near real time. Events are received from different sources of record in our Kafka, and transformations happen in the ACLs and APIs we have. They are in Golang. Kubernetes pods in AWS. They all write to Mongo collections. We have Mongo Atlas account where we write to from the pods. From the collections, we actually use this product from Mongo called Realm Sync to essentially sync them down to individual devices. And why we use Realm Sync, there's another slide I'll talk a little bit about why we chose this commercial solution versus bespoke solution. We also have local synced collections, so there are certain use cases we have for like images and syncing order data. We use local realms as a local database instead of installing like a SQLite or Postgres or something. We actually use local realms to store orders or whatever we need to store on the kiosk. Since Realm Sync actually syncs those collections down to the kiosks, they're inherently offline capable. So unless somebody goes in and physically deletes the collections from the device, they work without internet. So that was kind of a very important thing for us. Since I said, it's kind of money maker for us. So, it needs to be really hardened. It handles all the network nuances. So, jittery internet, latency, going offline for extended times, going offline during the app updates. All that is handled with Realm Sync. Again, power and network outages at the stores, there is always a lag by the time, there's no power and, when the generators kick in, there's a lot of nuances, where, some ingredients may have been locked, but the kiosks also shut down at the same time, so it needs to catch up to all of that. So this is all handled, we're handling in the Realm Sync. So this is what I was talking about. If we had decided to implement everything on our own instead of, say, using a commercial off-the-shelf software. That lettering, I think it's a big thing because network connectivity, in field, those devices get really, they get abused pretty hard. They're in front of customers. People click on them pretty hard. They get turned off. They get unplugged all the time. So one of the things what we did, designing the whole solution was we designed it in a way that the only action you can really take in field or in store on a kiosk is to restart it. So essentially, if there is some problem, a restart will fix it. Well, just like every Windows thing, right? So ORM, retry logic, error handling, app crash, and then pushing that data to stores. We're using Realm Sync for doing that, and that's a little more information about like how that kind of works. So you'll see from the right-hand side to the left-hand side at bottom in Mongo Atlas. So our API writes to those Mongo Atlas collections, right? And on the leftmost side, you see that mobile, but number 4 is actually a kiosk, right? So we use Atlas Device Sync or Realm Sync to essentially sync those collections down to the stores. Well, there's another caveat here because not all stores sell all products. So we do flexible sync where essentially only those items get synced down to the stores which are actually sold in that particular store. So say, think of Florida stores. I think there's a nuance where Florida stores sell a different brand of orange juice versus rest of the stores we have in our network. So So that is handled pretty nicely, with this. So it's just a query we add in, and based on the store ID, certain documents get sent versus based on a different store ID, certain documents and get sent to a different store. Transforming events to menus and ingredients to inventory. As I mentioned, so we do event streaming. So essentially, it's all asynchronous in nature. There we have multiple systems of record, lock-unlock events from stores in near real time, and then streaming of orders for business intelligence and inventory. So these were the things which we were solutioning for. And the solution we chose for doing that was, we chose Golang for implementing our APIs and ACLs. So application programmer interfaces and, anti-corruption layer, lightweight and fast. I think we already know that. So essentially what they do is they take events from different sources and combine them and aggregate them into a menu which a kiosk understands. So as I mentioned, the hardware on those devices is very, very basic. Like I'm talking like 4 gigs of RAM kind of basic. So all that heavy lifting happens in AWS, and a very simplified menu is actually synced down to those devices. And then, of course, updated near real time, based on whatever lock and unlock events we get from each store, because each store is different, and each store is freaking different, right? It does the heavy lifting, so the stores don't have to, like aggregation, integration with SAP. So for inventory management, whatever orders gets injected into our point of sale ecosystem also get sent to cloud, where SAP comes in and gathers all those orders and does its logic of reducing the inventory. So when things fall below a certain standard, they can be ordered. Same exact way, we also emit events when orders, are placed. So, business analysts can do analytics on, how the customers are really using the system, right? Or what are they buying really? Future support for our 3PL APIs is also coming. So think of DoorDash and Grubhub and Uber Eats. They of course need to show the menu, right? So customers can order, and that of course has to honor all the lock unlock, because you don't want people using DoorDash to order something which we don't have, right? Or we just ran out of. Some frameworks we use, Gin and Gorm for the APIs and ACLs. We also use Surama for publishing those events to our Kafka. This is the high-level architecture. Obviously, I can't talk too much details because that's secret sauce, right? So you can see here, let's talk from top left. There are different events coming in from different sources of record. We have catalog, we have lock-on-lock events, we have merchandisers changing up the menu, right? Being fed into Kafka, where our APIs actually pick it up and push it to our Mongo Cloud over private link. And if you see that blue arrow going down, those menu updates get synced down to individual devices or individual kiosks in each store near real time. Same way, these kiosks are actually always pushing metrics and health checks to our Datadog platform. So we know what's going on before the store manager tells us what's going on, right? And Google Analytics, how customers are using, what ingredients they're ordering on which screen, all that gets tracked, and we use measurement API of GA to do that kind of work. And then all the kiosks are also calling our integration platform in AWS for app updates, for images, videos, recommendations, talking about inventory, and then business intelligence. I think we already talked about the events which we emit when a customer places an order. As far as the metrics and observability is concerned, we went with Datadog. Very, very easy integration with multiple vendors. We ship logs from our Mongo cloud, from our local devices and AWS into Datadog, and very easily able to tie all these things together. Or at a glance, dashboards. So as I said, 4,500 devices, it's kind of hard to see them all in one view. So it gives a very, very good, high-level view, and also supports faceting. So we can drill down on store level, like see, hey, I want to see only the kiosks in this particular store to see how exactly they're, behaving, what version of app, they're doing. So in case of, say, Canary deployment, we're able to facet on, say, version 1.2.3. Let's see what's the health check on all those devices running that version. Say everything looks good. We can increase that rollout to more devices. For metrics, we use both Open Telemetry and Hotshots library. Datadog supports both out of the box. So for example, we use for health checks, we have for our pause injection API, we have for the Realm sync, whether, I think it's a critical information to know whether the kiosks are actually receiving the updates for menus, right? So all that gets tracked, using OTel. Hotshots, we use primarily for events. So for example, if an order gets rejected by our pause API for whatever reason, right? Say, misconfigured condiment, or store doesn't even understand what salt means, and it rejects the order. So all that gets bubbled up, pretty quickly, so we can take preventative action. It works really well with PagerDuty, and we use Google Analytics for user behavior. So right now, we only support anonymous user trends. So, we don't have a concept of a known customer. So if you go to a kiosk, or when you would go to this new kiosk, we would be able to know, like, what customers are buying, where, and how much. So essentially, whether a customer is buying because they organically chose, or whether it was because of a recommendation, we gave them. So things of that nature. We don't have a solution yet for real user monitoring. I know Datadog has an offering for that kind of thing, but they don't support Electron framework yet. I think it's coming in alpha version, so I think we might pilot with them to see how that works out for us. So essentially, it'd be good to be able to see, like, how customers are interacting, snippets, some sort of sampling, 1% of our users, let's see what they're trying to do, kind of thing. That's how our dashboards look like. You can see different health checks and, essentially you can see here just by a glance, last 15 minutes, one of the devices on the top has some issue with the health check. So it goes all the way to the top, and then the support staff can get notified using PagerDuty if something fails before the store manager actually tells us about it. And here you can see on top, all the different versions of different artifacts in the solution are being also rendered. And by the way, if you click one of those, it actually takes you to those logs, like where exactly those are coming from. And hovering over those actually also allows you to, at a glance, look at which of those machines, in that matrix, those versions are coming from. So it's very easy to correlate different pieces of data. That's it. Any questions?